The 1993 SAE technical paper on tomorrow's trucks highlighted the problem of cold water leaks as an important maintenance problem facing truck operators and suggested that improved clamps could help this problem. Gates Research has developed a solution to coolant leaks and in the process identified another significant problem, water permeation of silicone hose.
Let's look at the facts to see how the research suggests the use of two superior Gates products, Bluestripe coolant hose and the revolutionary new PowerGrip SB hose clamp. Let's see what Gates has done to address the overall problem of water or coolant loss from the cooling system.
Common causes of leakage are the continual expansion and contraction of hose and fittings as the engine heats and cools, and hose clamps that exert uneven pressure around the surface of the fitting. Performance under temperature conditions ranging from 20 degrees below 0 Fahrenheit to over 250 degrees varies widely for the three major classes of clamps: constant dimension clamps, constant tension clamps, and Gates' newest contribution to the field, polymeric clamps. Constant dimension clamps, such as the popular worm drive clamp, retain the same diameter regardless of the expansion or contraction of hose and fitting. Cold leaks are a common problem with these clamps. Constant tension clamps change diameter as the hose and fitting expand and contract. But Gates' new patented polymeric clamps, the new kids on the block, have properties that make them uniquely qualified to prevent leakage at the fitting. Let's see how. As you can see, both constant dimension and constant tension clamps allow gaps to form between hose and fitting, letting coolant leak from the system. This problem is magnified by fittings that are not perfectly round. Gates PowerGrip SB clamps maintain a tight grip on the hose and fitting under conditions of both extreme heat and extreme cold. The pesky cold leak is eliminated once and for all. Let's look at the laboratory tests that prove this. This apparatus is designed to measure the grip exerted on hose and fitting by a hose clamp at 8 positions around the circumference of the fitting. Here's a cross-section of the apparatus. A pressure measurement cell is located at each of the 8 sectors around the tester. A hose was clamped to the tester using each of the 3 types of clamps: constant dimension, a 1.75-inch screw or worm drive clamp; constant tension, a 1.75-inch spring steel clamp; and a 1.75-inch PowerGrip SB polymeric clamp. The apparatus was then placed in a temperature-controlled chamber which cycled 10 times from 80 degrees Fahrenheit up to 200, down to -20, and back again. This chart shows the load on the finger registering the least pressure as temperature was increased, decreased, then increased again. First, the screw clamp was tightened down in an 80-degree environment. The load drops slightly as the clamp digs into the hose, displacing some of the rubber. As the chamber heats up, the load stays fairly constant at about 85 pounds of pressure. As temperature starts to drop, the load, or clamp pressure, drops dramatically at first, then it slowly decreases further to about 5 pounds. When the load hits 0, leaking will result. And as you can see, with each additional cycle of heat and cold, pressure of the constant dimension clamp at the cold end decreases until it quickly dips to 0 pounds and allows gaps to form at temperatures as moderate as 45 degrees Fahrenheit. The only reason a connection would not leak under these conditions is the natural tendency of EPDM hose material to bond with the fitting under heat and pressure. No such bond occurs with silicone hose. The constant tension clamp seems to perform better than the constant dimension one, maintaining its grip on the hose and fitting as temperature dips into the moderate range. But as temperature dips below 0 degrees, load drops to 0, again inviting coolant leakage and increasing maintenance costs. Now the superiority of the PowerGrip SB clamp becomes clear. As temperature cycles from hot to cold and back again 10 times, clamp pressure on the hose and fitting remains within a consistent range of 20 to 45 pounds. Cold leaks are prevented even in silicone hose, which does not bond to the metal fitting. PowerGrip SB clamps eliminate the leaks you can see, but Gates research shows that there may be significant leakage you don't see. The problem occurs with silicone hose.
The glass-walled apparatus you're looking at was set up to demonstrate a significant silicone hose problem: water permeation. The Bluestripe hose section on the left and the silicone hose section on the right are each sealed in their own airtight chamber, with glass walls forming the front, back, and top of each chamber. A pump circulates water heated to 180 degrees Fahrenheit under 12 pounds of pressure, running through both hoses left to right, then back to the reservoir to be continuously heated.
Through time-lapse photography, we will see that the hot water escapes through the wall of the silicone hose at a rate many times that of the EPDM hose. In fact, the rate at which water escapes from silicone hose has been measured at 10 or more times the permeation of EPDM hose. This means a typical Class 8 truck operating at 210 degrees Fahrenheit with a 2-shift per day driving cycle would lose almost 5 gallons of water a year through silicone hose. This compares with a water loss of a quart per year using EPDM hose. While water molecules permeate the hose, ethylene glycol does not. This means that if you're replacing the lost fluid with a water antifreeze mixture, the concentration of ethylene glycol will increase every time the coolant is topped up. Over time, the effectiveness of the coolant is lost, decreasing cooling efficiency and raising the freezing point as the coolant becomes more concentrated. Supplemental coolant additive packages are often added to restore balance to the system. So if you're losing fluid through permeation, it's important to top up often and to use only water. If fluid loss is due to cold leaks at the fitting, a mixture of water and antifreeze should be used. And here's visual proof of the permeability of silicone hose. Over a 48-hour period, the silicone hose chamber has become markedly more humid than the EPDM side. These findings were recently confirmed in independent tests by a major truck manufacturer. So let's recap the evidence that Gates leads the way in designs for tomorrow's trucks. PowerGrip SB clamps never need retightening, so they are maintenance-free. SB clamps conform to any shape of hose or fitting, so even out-of-round applications never leak. SB clamps are made of a thermoplastic material that is unaffected by oil or other engine fluids, and they have an attractive professional appearance. SB clamps have no sharp edges, so they won't scrape knuckles during other maintenance. SB clamps are wider than traditional metal clamps, so the clamp covers more surface area, including the bead, which offers greater sealing capacity. One style of SB clamp covers all hoses, including delicate silicone and standard rubber hoses. SB clamps are made of heat-sensitive thermoplastic with a memory that prevents them from over or under tightening. They are environmentally friendly, eliminating antifreeze leaks and groundwater contamination.
Gates Bluestripe coolant hose, the standard of the industry, prevents significant water loss through the hose wall, eliminating the need for frequent water fill-ups and assuring the optimum concentration of antifreeze in the cooling system.
Unlike silicone hose, it bonds to the stem, helping to prevent cold leaks. It's resistant to electrochemical degradation, which can destroy ordinary hose from the inside. It costs less, and when used with PowerGrip SB clamps, it offers 750,000-mile durability.
Gates Bluestripe coolant hose and PowerGrip SB polymeric clamps, setting a new standard for tomorrow's trucks today.